Assalamualaikum warahmatullahi wabarakatuh. Today we will be present about timer 555. Let's watch the video.
Welcome everyone to today's explainer. I am so excited for this one because we are looking at an absolute legend in the electronics world. We're diving straight into the mighty 555 timer integrated circuit. If you've ever wondered how your gadgets keep time, blink an LED, or make a sound, well, the answer usually starts right here with this tiny piece of silicon.
This little chip dropped all the way back in the early 1970s, and honestly, it is still dominating modern electronics today. We are talking over 1 billion of these produced every single year. It's widely considered the most popular integrated circuit ever made, pretty much the ultimate industry standard. And today, we're going to find out exactly why.
Here's our quick roadmap for today. We'll start with the mighty 555 timer, look inside the 8 pins, compare astable and monostable modes, check out some real-world applications, build a buzzer project, and wrap up with why this is a timeless tiny chip.
Let's kick things off with Section 1, the mighty 555 timer, a tiny electronics legend.
So here it is in that classic 8-pin package. Rumor has it, it famously got its 555 name from its internal architecture, which features 3 5-kilo-ohm resistors. This thing is incredibly versatile and super reliable, mainly because it handles a really wide voltage range, from 4.5 up to 15 volts. That makes it totally perfect for simple, small battery projects or massive, complex industrial systems alike.
Moving right along to Section 2, inside the 8 pins, anatomy of the chip.
If we zoom in and look under the hood, the internal circuitry is just elegantly simple. Right up at the top is the internal voltage divider, those 3 5-kilo-ohm resistors I mentioned, and they establish your critical reference levels. Then you've got 2 operational amplifiers acting as comparators to monitor the voltage. They feed straight into a built-in digital flip-flop circuit right in the center. It is this beautiful combination of analog comparison and digital logic. Out of the 8 pins, these 4 are absolutely crucial. Pin 2 is the trigger, which kicks off the timing operation. Pin 3 is the output, the muscle that actually drives your components, like an LED. Pin 4 is the reset, which will immediately stop the timer. And Pin 6 is the threshold, monitoring external voltage to eventually tell the cycle to stop.
All right, Section 3, astable v monostable modes, the 2 superpowers.
The 555 basically has 2 main operating modes. Astable mode acts as a free-running oscillator. Think of it like a continuous heartbeat or a metronome. It just switches on and off automatically without you needing to push anything. Monostable mode, however, has one stable state. It's exactly like a microwave timer. It sits there doing nothing until you trigger it, does its job for a preset time, and then stops. A classic one-shot timer.
Which brings us to Section 4, real-world applications. Where does it live?
Because it's so incredibly reliable, the 555 is quite literally everywhere. That monostable one-shot mode gives you the perfect delay for things like automatic corridor lighting or automatic doors. And the astable heartbeat mode, that continuous pulsing powers flashing traffic lights, wailing security sirens, and even controls the speed of small DC motors in your battery-powered tools.
Okay, Section 5, building the buzzer project, theory to reality.
Taking this from a paper schematic to a real physical breadboard is honestly super simple. We're going to pair our 555 timer with a flip-flop IC and power the whole thing with a 9-volt battery. We just add some carefully chosen resistors and capacitors to dial in our timing, plus a buzzer and a red LED for our output indicators. It might look complex, but it's really just a matter of connecting those pins we just learned about. So here's exactly how our circuit works in 3 simple steps. First, the 555 timer runs its cycle until it hits our specific preset timing condition. Second, that signal triggers the external flip-flop IC. And third, bam! The buzzer sounds off with a loud tone and the LED lights up bright red. We've just built a perfectly reliable hardware-driven alert system right from scratch. And finally, Section 6, a timeless, tiny chip. Summary and beyond. You know, in an age where everything is smart, connected, and programmable, the 555 timer stands out as a monumental achievement in semiconductor design. For one really beautiful reason, it requires absolutely no software coding. Because it relies purely on a direct hardware-driven response to an electrical stimulus, it is practically immune to code crashes. You never have to worry about a buggy software update breaking your automatic lights or your alarm siren. It just works every single time. So, I want to leave you with this final thought. What are you going to build with your first 555 timer? We put together a really cool alert system today, but the possibilities are basically endless. Grab a breadboard, grab some components, and start experimenting. Thank you so much for joining me for this explainer on the legendary 555 timer. Keep tinkering, keep learning, and I'll see you next time.